Alright, here we go with day 2 of 11.5. We are going to be introducing some wonderful trigonometry into our regular polygons. But first, a special, exciting, wonderful, cool formula for equilateral triangles. Do you need to know this? No. You can figure it out with 30, 60, 90 triangles like we've done in the past. We've already done that. But this could save you a little bit of time. Okay, so if you have any kind of equilateral triangle, you can plug in your side, if you know the side of that equilateral triangle, you can plug it into this bad boy right here. Here it says find the area of an equilateral triangle with a side of 2 root 3. So if I were to plug it in, I'd have 2 root 3 squared root 3 over 4. 2 root 3 squared is, well, 4 times 3, which is 12 root 3 over 4, so 3 root 3. Boom. That was pretty easy, right? Units squared. Now, let's think about the alternative here. What we used to do, or you still could absolutely do, if I had an equilateral triangle, I would drop an altitude, thus splitting the side into 1 root 3 and 1 root 3. So this is root 3 and root 3. The whole thing is 2 root 3. And I'd need to find my height, right? I need to find this guy right here to do 1/2 base times height. I've got my base of 2 root 3, but I need my height. Well, this is a 60-degree angle right here, so I'd be like, okay, well, I got to multiply that by root 3. So I do that. Root 3 times root 3 is 3. All right, so I've got my height. So 1/2 times my base of 2 root 3 times my height of 3, I've got myself, well, 2 times 3 is 6, times 1/2 is 3 root 3 units squared. Same answer. I guess, a little bit longer. It's not a big deal. Either way, you're going to be able to figure it out, right? It's not like there's a certain situation where I know this and I can't answer the question otherwise. No, it's just basically like a little extra easy to work with formula if you do remember it. If you don't, no big deal. If you do, it could save you a little bit of time. Alright, so we want to find the apothem, perimeter, and area of a regular nonagon with radius 5 feet to the nearest tenth. So we will be rounding here, but we will wait till the very end. Hashtag YORO. Of course, you only round once. Alright, the other video, the 11.5, we were leaving it all exact. Exact has fractions and radicals. Decimals are not exact, even though you guys continue to think that they are. If you've rounded them at any point, it's not exact. All right. So let's see here. A nonagon, I'm not going to draw the whole nonagon. What I like to do is I go like this. I draw like 3 sides of it. Okay? And I'm going to take this guy here, and I'm going to make a triangle. I'm going to drop my apothem or my altitude, whatever you want to think of it as. A goes right there. Okay. Now, what's important? Well, I've got the 5 feet for my radius. Again, I'm basically just creating right triangles, creating triangles when I do this to solve the problem. So I need my perimeter. I need my apothem. I have none of those right now. But then I can plug it into the 1/2 apothem times perimeter formula, and away we go. All right. Well, I guess what I could get is if I took 360 and I divided it by 9, I could then get my central angle. Right? So if I did that, let's see here. If I went and took this guy, I could get that guy by doing 360 divided by 9. And that's going to be 40. And half of that will give me my other one, 20. Booyah. Which makes that guy 70. Not that that's necessary, but it's a fun fact. Okay. So Kotoa will be used here. What am I going to use? Well, if I want my apothem, let's just focus on the apothem right now. If I'm looking at it from the 20-degree angle perspective, right, from over here, this is my adjacent, this is my hypotenuse. So I'm going to be using cosine. Cosine of 20 equals my adjacent, which is my apothem, conveniently the same letter, over my hypotenuse. So multiply by 5, and I get A equals Well, my apothem is going to be, let's see here, cosine of 20 times 5 is going to be 4.6984, blah, 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 blah. So I'm just going to write down 4.698 for now, right? So I have it stored in my calculator. So that's my apothem. Now I got to find my perimeter. I can do it the same kind of way, but I'm looking for my opposite now. So instead of using cosine, I'm going to be using sine. Sine of 20 is equal to my opposite, we'll just call it x, over 5. So I'll do sine of 20 times my hypotenuse, and I get x equals 1.710. So on and so forth. Well, how do I get my perimeter? Well, first I got to basically double that to get the whole side. So it's like 3.4-ish. And then I got 9 sides, so I'm going to multiply that by 9 to get my perimeter of 30.7818, so on and so forth. I'm not rounding, right? I'm just leaving them there for now. Now I can plug it into my formula, 1/2, so 0.5 times. I'm going to go up and grab that apothem, which is the 4.69846, blah, 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 blah. And then my perimeter of 30.78 whatever. And I'm going to get, now I can round, area equals 72 point, and it says nearest tenth, so 3, and it's feet squared. There we go. All right. Had we rounded along the way, you'd get a slightly different answer. So we don't want to do that. Round at the very end. Yo, row. You only round once. That way we're more accurate. We're all consistent. And it's not like, wait, why did you get a different answer? This is a nice way to be consistent and accurate. Alrighty. We're just going to do a couple different types of problems. All the same type of deal, but different information given, so it seems a little bit of a different situation. Find the apothem, radius, and area of a regular pentagon with perimeter 60 centimeters to the nearest tenth. So I've already got my my perimeter, which is nice, 60. So what I'm going to do is I'm going to draw out my, I guess I shouldn't have it all like curly Q-y, but I like to draw out my portion of a regular polygon. There's a dope voice crack right there if you didn't catch that. And if I've got 5 sides, because it's a pentagon, 5 sides with that, 60 divided by 5 is 12. So 12 for the side, right? 60 over 5 equals 12. Okay, which means that I get 6 for each of these guys, which can help me figure out my apothem. Well, I need something else. I need an angle. Well, I know there's 360 degrees in a circle, which would be all my central angles of this pentagon added up. There's 5 of those central angles. So if I do 360 and I divide that guy by 5, I end up with 72. And if I divide that in half, I would get 36 for each one of these angles. Okay? So now I'm just dealing with a right triangle with this angle. I know my opposite side of 6. I don't know my apothem, which is my adjacent side. So Katoa will help us solve this. Opposite, adjacent, tangent. Okay. So the tangent of 36 is equal to my opposite, which is 6, over my apothem, which is my adjacent. Coincidence that, again, that it's the same letter, which is lovely. So I'm going to have to multiply by a. This is like a slightly more to it problem. And then I'll divide by tangent of 36. So a is equal to 6 over tangent of 36. That's what I'll plug in my calculator real quick. So 6 divided by tangent of 36. And I end up with 8.258, so on and so forth. 258. Okay. So my area is equal to 1/2 times that 8.258 times 60. I'll plug that all in. So times, see here, boom. And I'm using all those long decimals in my calculator whenever I need to. And my area ends up being, now I can round, 247.7487, so on and so forth. It says nearest tenth, so just 0.7 centimeters squared. Boom. I like it. Lovely. All right, basic name of the game there with these guys is figuring out an angle, and you're also probably given some kind of a measurement that you can use to set up your right triangle trig. All right? It's pretty much all it is here, and then plugging your information into that area formula. But setting up a right triangle, getting an angle, getting a length of something, that'll help you do it. All right, find the area, perimeter, and radius of a regular octagon with apothem 4 inches to the nearest tenth. All right, same kind of dealio here, guys. I'm going to set up my part of a regular polygon. Boom. Drop my apothem, which I do know is 4 for this one. And then now I need to figure out what else. I got to get my perimeter, so I need this side of that right triangle I've just created to do that. Well, I need an angle, but I bet you I can figure out my central angle and then divide that by 2 to get that angle that I just pointed out. Well, 360 in total divided by 8 is going to give me 45, right? So 360 divided by 8. Why did I choose 8? Octagon. That's 45. If I cut that in half, that is 22.5 degrees for that angle. Awesome. I can use that and figure out what my missing side is. So in this case, since I'm looking for the opposite of that angle and I have the adjacent, once again, we're using tangent. So tangent of 22.5 equals my opposite over my adjacent, which is 4. Multiply by 4. And I get, kind of looks like a 9. That's a little better. Let's see here. Tangent of 22.5 times 4. That gives me 1.6568. So 656, so on and so forth. Right? I'm not rounding yet. I've got to double that to get the whole side, which is 3.3137, 313, so on and so forth. And I've got 8 sides, so let's multiply that by 8. If you decide to multiply by 16 right off the bat, that's cool too. So my perimeter is 26.50966799, so on and so forth. All right, so let's plug that into my formula. Area equals 1/2 times my apothem of 4 times my perimeter of 26.509, so on and so forth. Alrighty, I'll multiply that all in my calculator, my trusty old TI-84, and I get, I'm out of room with where I can write nicely, so I'm just going to put it up here. I get 53 point, and it says nearest tenth, 0.19, so 0 inches squared. That's what that is right there. That's my area. Oh, I didn't answer everything though. I got my perimeter, I got my area. Check, check, but what's my radius? Well, I'm going to need a little more room to do this now. But let's get that radius because it asks for it. It's not useful for our area, but it does ask for it. Let's see here. My radius is going to be, well, I could use some trig, right? Let's call it R. That makes sense. I know my angle is 22.5, so my adjacent is 4, my hypotenuse, cosine. My adjacent over my hypotenuse, I'm going to multiply by r, and then I'm going to divide by cosine of 22.5, so r is equal to 4 over cosine of 22.5. Let's see what that is. R is equal to 4.329, so on and so forth, so 4.3 since it's nearest tenth, and that's inches. Cool. There we go. What a wonderful, exciting problem. Again, right triangle trig. You get some kind of measurement. You get some kind of angle, right? You get some kind of length. You get some type of angle measurement. And we're off to the races with trig. Exciting. So much fun. Alrighty, so again, don't pay attention to the whole quiz thing. We actually changed the sections that it's over as well. And those dates changed. But that homework right there and the worksheet that is posted online are your problems you should do. Lovely. Cool.